Alright, let's look at our first set of material for this semester. So we're in section P4. Okay, so that's preliminary. So this is stuff you're already supposed to know, but most people need a refresher on some of these topics. So I will do a short video here. This section really has two parts. Okay, part 2 is just really the last problem. So I'm going to post a separate video tomorrow just for the last problem. I want you to just be able to focus on that one topic in that video. Okay, so in this section we're going to talk about exponents. Okay, so we've got 3 exponent rules. The first one is that if we have terms that have the same base, so I'm making both of these have the base x, okay, and we multiply those, then the way we deal with the exponents is we add them. Okay, so we have whatever the number n is plus whatever the number m is. If we have terms with the same base and we're dividing them, so x to the n over x to the m, then our rule is that we subtract the exponents. Okay. And then rule number 3 is that if we have some term with an exponent and we're raising it to a power, so x to the n to the m power, write that a little better. Okay, then we multiply. So anytime we have two of the little numbers together, we multiply, so we get x to the n times m. Okay, so let's look at these with some numbers involved. So if we have x squared times x to the third, we're going to add our exponents, get x to the fifth. We have something like x to the seventh divided by x to the fifth. We're going to subtract, and when we subtract, you put the exponent on top first. If you have any negatives in there, you have to be really careful with the signs. Okay, but here we have 7 minus 5, so we'll get x squared, or x to the second. Okay, and then if we have a situation like x to the third raised to the fourth power, then we're going to multiply, so we'll get x to the 12th power. Okay, a couple of examples for got a little bit more of the trickier situations here. You can use all these rules in one problem. They're not just going to be a problem with just one rule involved most of the time, but sometimes there are. Okay, but if we have something like this where we have a number coefficient, so we've got 3 x squared raised to the third power. We have to be careful here because we really have 2 exponents inside our parentheses. It's easy to forget about the exponent on the 3, but since it's not written, the exponent on the 3 here is a 1. So when we multiply our exponents, we're going to multiply the 3 times the 1, and we're going to multiply the 3 times the 2. So what we'll get here is we'll get 3 to the third power, 3 times 1, x to the 6th power times 2. And then this we can simplify a little bit. 3 to the third power means 3 times 3 times 3, which is 27. Still have x to the 6th there. Another thing that can be a little bit tricky is if we have negative exponents. So really quickly, the way you deal with negative exponents is if we have let's do this. If we have a situation like this, like we've got x to the negative 2 and y to the negative 3, so the way you switch the sign on the exponent, you can make the exponent positive if you move that term to the other side of the fraction bar. So what I'm saying is this term, it starts out in the top, so we can move it to the bottom, and that will make its exponent positive instead of negative. The y term, it starts out in the bottom, so we can move it to the top of the fraction, and that will make its exponent positive instead of negative. This thing here, if we do that, we move the y to the top, so we're going to have y to the positive 3 in the top, move the x to the bottom, and we'll end up with x to the positive 2 in the bottom. If you have negatives in the top and in the bottom, you can think about it like flipping, and we just flip this thing over. You're not always going to have just negative exponents though, so it's good to know what to do with each individual variable. So let's look at an example here. So let's look at this problem. Okay. X squared times y to the negative 1 power x to the negative 6th power. Okay. So you can do these in a couple of different ways. To me, the very first thing I like to do is get rid of the negative exponent. So that means this term's going to move up to the top because it has a negative exponent. This term's going to move down to the bottom because it has a negative exponent. So if we rewrite that, then we get x to the 6th that goes in the top, and then times x squared. And now we have a y to the first power in the bottom, and you don't have to write the first power if you just have an exponent of 1. Just leave it off. Then what do we get? We use our rule number 1. If we're multiplying, we add our exponents. So on the top we get x to the 8th. Bottom we get y. Okay. One other thing I want to cover briefly here. What if we have a situation like this? We have radical, some variable with an exponent. So we would say this is the nth root of x to the nth power. Well, the thing to remember in this section, since we're talking about exponents, is that we can rewrite this anytime we have a radical. We can rewrite it as a fractional exponent. And the way we do that is whatever number is out here, whatever number is on the radical, call that our index, that's going to be the denominator, the bottom of our fraction. So this thing is going to be x to the n over m power. So let's think about what that would look like with some numbers. So maybe we have the cube root or the third root of x. Just an example. Well, if we rewrite that in exponent form, exponent on the x is 1, so we end up with x to the 1/3 power. What if we have the 5th root of y squared? So the index is 5, the number on the radical is 5, so that's going to be our denominator, so we're going to end up with y to the 2/5 power, or y to the 2/5 power. Okay, and then one that's easy but can look confusing, what if we just have square root of x? Well, if you don't have a number written out here, that means that it's implied, okay, it's just understood that square root, our index, is 2. So square root of x, that would be x to the 1/2 power. The other topic that's covered in P4 is rationalizing expressions with radicals in the denominator. I'm going to make a separate video just because I think it needs its own little video, so you can just refer to it when you need to. I'll post that tomorrow. Okay, but other than the very last problem on section P4, you should be good to go just with these examples. Let me know if you have any questions.